Right. In last class, what we were discussing about, it was discussing about ellipse and the hyperbola. Uh, ellipse. Ellipse here. So when you're discussing about the ellipse, the basic equation was x squared over a squared plus y squared over b squared is equals to 1. So if you happen to draw this kind of a graph, it's a shape like this way around. This is a and this is minus a and this is minus b and this is b, right? Okay, so according to this one, this is the parametric Cartesian equation for that. The parametric equations for this one become a x equals to a cos t and y equals to b sine t. This was the parametric equations for that. That was the main concepts we discussed in the last session. Then the next fact we were discussing was that is hyperbola. Yes. When you're discussing about this hyperbola, it was a shape somewhere like this. So if you just concern about a shape, it came somewhere over here like this way and this way, and we've already driven two lines which shows you the shape, basic shape of this. So the equation was x squared over a squared minus y squared over b squared is equals to 1. That the previous one was plus, this one would be negative. If this is a, this value become a, and this is minus a. This line is y equals to b over ax, and this is y equals to minus b over ax. Minus b over ax. That was the two lines we were discussing in this much. So make a, if you want to go ahead with the parametric equations, basic parametric equation is x equals to a cos t and y equals to b sin t. From the hyperbolic formulas where we already learned these facts, and this is the using the hyperbolic functions and uses the trigonometric equations. You can say this is the most prominent equation we have used in our activities, but this one also some situations there we also use y equals to b tan t, tan theta. From here even you can get these facts, right? Okay. Right, okay. So those are the basic facts we have been discussing about in our last class, right? Okay. Today we need to learn about the new approach for this, that is called the eccentricity. Eccentricity. Right. Eccentricity means, Pute, you can see any of this hyperbola or parabola or like ellipse. We already learned eccentricities in our AS level when you're discussing about the coordinate geometry. That means what we need to understand is we will get a point called focus. Focus, and we already learned there is a line that is we already labeled this line as directrix. Directrix, right? Then if you get any kind of a point in a way, we already learned this one in our AS level. This way, if you get some kind of a point, I'll get this point as Sn and this point as P, and I just make a perpendicular distance to this, to the directrix, that is M. We can define any kind of a locus using the distance between SP and PM. So any kind of a locus, just like this, you can define using these ones. Point again discuss karna puluwan. So if you define the locus in this kind of a way, so what do you call that? If you get the ratio between PSM and PM, so you can say the ratio, I just the ratio between SP and PM is called the eccentricity E of a shape. Okay, right. Usually we get PS over PM. PS over PM is equals to E. That's a fact of eccentricity where we defined today. Then, what are the properties of this PSN and PM where we can understand that today, right? මෙතන තියෙන fact එක තමයි පුතේ if you can say E is in between 0 to 1, it cannot be negative. If it is between 0 to 1, we can say the design shape is a ellipse. It's an ellipse, right? Then if it is E is equals to 1, if it is exactly equals to 1, it's turned up into a parabola. We already learned in our AS level this much, parabola. AS work we learn. And the third fact is that if E is greater than 1, we call it a hyperbola. Those are the facts where we have already learned in our under this eccentricity. These are the facts to be learned, right? Now let's see what kind of approaches we should know about these concepts. Right? I just minimize this, then you can see the basic things where we have already started from this one. Okay, right. Let's go ahead. So you should make it. Now they might give a question like this. So if you go to this, the first exercise, example 5 in page 23, they ask, they give us a question somewhere like this. Example 5 I'm discussing about. Example 5, then say 4, E is in between 0 to 1. 0 to 1. Ellipse with focus AE, 0 and directrix x equals to A over E. Has equation x squared over A squared plus y squared over B squared is equals to 1. We need to show this. Now let's go ahead with this, right? Okay. According to this one, this is the way, right? According to this one, the focus is this way. The focus is AE, 0. And this is the origin. 0, 0. We have already drawn the directrix. It's just like this. X equals to A over E. Right. Then we will get any point on this line. Any point over here. General point, general coordinate X and Y. X and Y. And I will draw two lines. So this is S. I just get P and this is M perpendicular to this. Right. Okay. Then here the coordinate is, if you consider the coordinate, general coordinate over here, so we will write, consider any coordinate that we call general coordinate xy. P, right? Okay. Then if you get the coordinate over here, the x coordinate is how much? A over E. It's parallel to this. The other y coordinate is y, right? Then what you need to do is, we have to find out a relationship like this. But initially, I try to get the length of PS. But PS, P to S. So you can say x minus AE whole thing squared plus y minus 0 whole thing squared. The square root would be the length of PS. But then if you get PM, PM is equals to, here you can understand the y coordinate is same thing. Here that is A over E is the x coordinate minus x squared plus y minus y. I'll just get this one, that it makes you kind of a less confusion when you're working out with this. So we can get the length of PS and PM like this. Then if you get the relationship like this, so if you get PS over PM, there is a relationship no? PS over PM is equals to E kala. So what happened here is, that is the square root of x minus AE whole thing squared plus y squared divided by the square root of A over E minus x whole thing squared plus y minus y 0 squared is equals to E. Then I'll square the both sides. If you square the both sides, what you get here is, yeah, x squared plus minus 2aex plus a squared e squared plus y squared is equals to e squared times of, if you expand this a squared over e squared minus 2ax over e plus x squared. Then if you multiply with this e squared, what you get here is like this. X squared minus 2aex plus a squared e squared plus y squared is equals to, here this a squared minus 2aex plus e squared x squared. So now you can understand that here I can cancel this term with this term. Okay, then I'll just take this one over here. X squared, I'll take this term to the other side, minus e squared x squared, then y squared terms just like this. So you can say plus y squared, and from these two, I can say like this. A squared e squared minus a squared is equals to 0. We will just try to do something. Then from here, I can take x squared out. 1 minus e squared plus y squared is equal to, if you take a squared out, that is e squared, sorry. We'll just do it in this side. I will just try to take these two terms to other side. Here. Then it's turn up to a squared minus a squared e squared. Then you can write 1 minus e squared plus y squared equals to, from here, if you take a squared out, 1 minus e squared. Right. Right. Then for our expression over here, this value should be 1. Therefore, I will divide the entire expression by this way. I will divide the entire expression by a squared times of 1 minus e squared. That's what happened here. It's turned up to x squared 1 minus e squared divided by a squared 1 minus e squared plus y squared over a squared 1 minus e squared is equals to 1. Our objective is to make this as 1. Therefore, you can say this is in form of, therefore, the equation reduces to form of x squared over a squared, cancel here, plus y squared over b squared is equals to 1, where b squared is equals to a squared times of 1 minus e squared. And to perform this, definitely if it is a square root square value, the condition is e should be less than 0 to 1. Other than that, what happened here, this is not existing. Right. Okay. So that is the fact where we have to understand in this question. If you can understand how I did this, I'll just put the full question into one screen. Then you can understand how I did this question. That's a way of getting it. Right. Okay. Then, yeah, let's go to the next extent. Right. Then over here, then you can write, if you get any kind of a ellipse, these are the properties you can see today. So if you get any kind of ellipse, x squared over a squared plus y squared over b squared is equals to 1. The ellipse generates in this way. This is A and this is A. And but the focus is AE because you know that A is a less than 1 value. Therefore, AE comes to this point. This is AE. That's a factor to understand. This is minus AE. And eccentricity. Eccentricity is x equals to a over e. Since a over e is a value less than 1, eccentricity comes to outside from the diagram. That's a factor to understand. So here this is x equals to minus a over e. Right. But according to this one, b squared should be similar to a over e. That's a fact where we can understand from this kind of a question. Right. Okay. Right. So if any case, if you need to find E, we know that this one today. How to find E? That's a question where we come across today. So we know that B squared is equals to A squared times of 1 minus E squared. Then you can say B squared over A squared is equals to 1 minus E squared. E squared is equals to 1 minus B squared over A squared. Therefore, E become square root of 1 minus B over A. B squared over A squared, that is it. Right, okay. From here you can get it. But this formula we use this if E is for this question, we can use this one in this way. B is less than A value. For this kind of situation only we use, right? Then if B is greater than A, the relationship we use is A squared is equals to B squared times of 1 minus E squared. That's a fact we used to get if they are the other condition. So that is a two different, not different, it's same approach, but we use different, what do you call that, different kind of, same kind of formula with what do you call that, reconstruction to make it into a proper way of understanding the proper value of A and B. That's a way of getting it. Okay. Right. Let's go ahead to the question and try to understand how this is happening. Yeah. The first question is if you just get x squared over, we will get 9 plus y squared over 4 is equals to 1. So this one you can say x squared over 3 squared plus y squared over 2 squared is equals to 1. Right? Okay. According to this one, if you just draw this, basically you can get a ellipse like this. This is not a perfect drawing, but this is 3 and this is minus 3 and this is 2 and this is minus 2. So you know that this one, according to this one, 3 squared is equals to, sorry, the other way around, because here the B is greater than A. This one you can write 2 squared is equals to 3 squared times of 1 minus e squared. So from here, 4 is equals to 9 minus 9 e squared. Then you can say 9 e squared is equals to, it's 5. Therefore, e squared is equals to 5 over 9. E become root 5 over 3. Right. Then the focus. Focus is equals to AE. That is, A is, according to this one, A is 3 times of root 5 over 3. That is turned up to root 5. So here, the center become root 5, and this is minus root 5. Then eccentricity. Sorry, directrix. Sorry. Directrix is equals to A over E. A is, according to this one, 3. E is root 5 over 3. It is equals to 9 over root 5. Yeah. Then we can write the directrix. X equals to 9 over root 5, and over here we can do x equals to minus 9 over root 5. That's a way of getting these values. Okay. Hope you can understand how it comes. Yeah. Okay, Pute. Let's go to another example over here. This is x squared over 16 plus y squared over 25 is equals to 1. So this is turned up to x squared over 4 squared plus y squared over 5 squared is equals to 1. So if you just draw this, you can understand that, but there is certain things where we understand. Over here, this is 4, and this is minus 4, and it has a shape somewhere like this, 5 and minus 5. Minus 5. So according to this one, Pate, you can say B is greater than A. Then you can write 4 squared is equals to 5 squared times of 1 minus e squared. So therefore you can say 16 is equals to 25 minus 25 e squared. Then 25 e squared is equals to 9. Yeah. Then e is equals to 3 over 5. Okay, then what you can understand is, Pute, from here, if it is become, then we mark the focus on y-axis, Pute, not in x-axis. If this is the situation, if this is y is greater than this, we mark the focus over here. The focus comes to this axis, Pute. That is, then you can say focus. Focus is equals to y equals to b over e, Pute. That is a way of getting that fact, Pute. Then the focus is equals to y equals to. Then directrix should be equals to y equals to b over e. B is 5, e is 3 over 5. That is 25 over 3. Yeah, then we can mark the directrix like this way. y equals to 25 over 3, and over here you have to be very careful with this. It is y equals to minus 25 over 3. These are the directrix we have to draw with this kind of a diagram. Yeah, so those are the situations we should know in this kind of question. Okay. Okay,